Hello! Welcome to Polymath-ish. I'm your host, Storm Hardy, and for the past 4 years, I've been obsessed with aliens. I'm not out here watching UFO videos, but I do genuinely believe alien life is out there. The countless stars and countless habitable worlds out there must house another sibling species to us, another sapient. When I think about aliens, I tend to do it from a scientific lens. Specifically, I use my understanding of evolutions and its patterns and trends to figure out what they may be like. I study the planetary bodies needed and the physics involved in every facet of survival. In that way, life is like a game of constantly edging out competition, using our universe and its physics as the game engine and rules. As you see, I have a true passion for this. So before I go on to some long-winded tangent about evolution and my love for it, let's get you acquainted with an important term. Convergent evolution. Convergent evolution is the process where unrelated organisms independently evolve similar traits because they have adapted to similar environments or ecological niches. An important part of this is the similar environments. We all inhabit a shared environment, with its rules and constraints being the laws of physics. With just the similarity to how the universe works, some traits may be universal. That is where we are going to be exploring today. I am going to separate this analysis into 3 sections: non-microscopic moving animals, prerequisite requirements for a civilization-capable species, and technological and scientific capabilities. Without further ado, let's get into the convergent traits for macroscopic motile animals. All of life relies on mutation and storage of information. Without these two things, species literally could not evolve. They could not mutate new traits or retain those traits for future generations. So our first trait is a variable and non-static mutation rate subject to selection itself. To put it more simply, it needs to be able to mutate, and the rate at which it mutates should also be subject to mutation. To properly have both mutation and stable inheritance simultaneously, you need a digital hereditary scheme, like DNA or ones and zeros, instead of a continuous system, like analog systems or floats in a computer. You see, Manfred Eigen realized there's a hard mathematical limit on how much mutation a hereditary system can tolerate before the information simply dissolves. This limit is now called the error threshold. The amount of mistakes a continuous system can make is essentially infinite. The original information disappears no matter how strong selection is. This is the error threshold. Discrete systems like DNA have one where you can stay below, whereas continuous systems push the threshold all the way to 0. There is a very high chance that our aliens will be bilaterally symmetrical, like a mirror in the center of the body. We humans, for example, are bilaterally symmetrical. Even species on Earth such as octopus, which originally evolved to have radial symmetry like a starfish, evolved a frontward-facing and bilaterally symmetrical body plan. This is only if our animal is a non-microscopic moving animal. I think this is a fair assumption. By animal, in this case, I mean heterotroph, something that doesn't create its own food like plants, and is capable of movement. I highly doubt that a photosynthetic life form would have the selection pressure all the way to build civilization. Food is easy for you when you're a tree and all you have to do is stand and look pretty. Likewise, because our creature needs to eat to survive, it will likely have a dedicated intake opening for food, what we would call a mouth. In tangent with this, it would need a separate waste outlet that would typically be on the opposite side of the body from the intake. This is what we would call an asshole in humans. Hello? Oh, I'm just being told now the proper term is anus. Okay, bye Mom. Love you. Sorry, that was my agent. Sensory organs like eyes, ears, smell, or others will group up and gather near the mouth because it's really useful to A, sense where you are going, and B, sense what's going into your mouth. The processing part of the body, neurons for us, will cluster adjacent to the primary sensors. This combination of mouth, sensors, and processing creates a structure much analogous to a head. Civilization is built on a repeating cycle of communication and discovery, or invention of new tools. These new tools, or new ideas, are communicated and passed on to others and eventually future generations. These new tools facilitate the construction of more advanced tools based on the ideas of previous peoples. So a civilization species first needs the ability to even make tools. It needs to be able to manipulate objects with precision and force to create new tools. This construction of a new tool is useless if you can't communicate it to anyone. Okay, maybe not useless for you, but useless for your overall species. I can definitely think of a raccoon who would love to learn how to build my house key, whether he could communicate the ability or not. Seriously though, a civilization species needs a generative symbolic medium capable of synthesis of arbitrary and abstract information. In less fancy words, you need a language of some form. It doesn't need to be audio, it could be visual, pheromone-based, or some other strange method of communication. Now the really interesting thing here is the vast amount of ways these two traits can be accomplished. For example, a eusocial ant-like species could be capable of precision work as a hive, and can communicate ideas between hives instead of individual ants. This would be a civilization of hives, a rather wild world. Or take a dolphin-like species that domesticates a semi-aquatic species. The dolphins may not be capable of precision work themselves, but the semi-aquatic species is, and the dolphins use them to build their tools. And then you have us, old Homo sapien. Maybe to some alien species, we're the novel case. The first thing any technological species will need for advanced civilization is a low-tech, highly controllable source of high-grade energy. For sapiens like us, that was fire. But I've brainstormed a few semi-realistic solutions other than fire. For example, a species could concentrate sunlight onto a point, reaching large amounts of heat. This is probably better on a non-oxygen planet that still gets a lot of sunlight hitting the surface. You could also tap geothermal sources of heat, which is actually one of the only ways I could envision a high-tech civilization coming about in an underwater scenario. The last semi-realistic option is naturally radioactive materials being used to create heat. This barely beats the threshold needed for kickstarting your tech tree. To actually reach space, though, they need launch capabilities of some kind. There may be some strange outlier, but 99.9% of the time this will be rocketry. They'll also require mathematics to understand orbits and basic planetary science, such as knowledge of gravity and orbits. Now, this last trait is either or. Either they have the capacity to create artificial biospheres so they can travel as stars themselves, or they have advanced robotics to do it for them. Neither is guaranteed, and a civilization could be capable of both. But for them to be truly spacefaring, they need something faring space. So our aliens are here. Well, only conceptually. We know they will have a head with a brain and senses clumped there. We know of its anus. We know it has limbs capable of precision manipulation, or at least some animal capable of doing that for them. We discuss early ways their technological journey could start out, and the traits that are absolutely essential for space travel. Yeah, I'm gonna be honest, we didn't learn a whole lot about the aliens. This is because even when we try to constrain their possible traits with things like needing to do precision work, they can get around it with some strange workaround. Life is full of these strange workarounds. Maybe that's the point of this video. Not what we can figure out about the aliens, but what we can leave to imagination instead. If you enjoyed the video, please be sure to like and subscribe. Thanks for watching.